Hi, and welcome to Techniques and Practices for Testing Angular 2. I'm Adam Stephensen. I'm a solution architect and the general manager of SSW in Queensland, out in Australia. My primary responsibility is I'm in charge of making sure that we ship large enterprise web applications. And I'm also a mentor at Fire Bootcamp, which is where we do a whole lot of Angular 2 training through SSW.
Hi everyone, my name's Duncan. I work with Adam in Brisbane, Australia. I'm a software architect at SSW, and I've been really lucky just to do pretty much only Angular for the last couple of years, Angular 1 and 2, all in TypeScript. Been involved in about a dozen projects, and we've been lucky enough to train and do lots of code reviews over the last probably year and a half while Angular's been kind of moving through alpha and beta into being released in Angular 2. And now we're finding a lot of people, because it's Angular 2's released, are actually at the point where they're writing their applications, and the first thing they do when they actually kind of start is go, well, actually, we need to test this. So we've found a lot of people have been very interested in talking about testing with Angular 2 now that everyone's actually kind of getting into production with it. So hopefully we can share some of the tips and tricks along the way we've learned in a lot of that teaching.
Awesome.
So also you'll hear us say Angular 2 a whole bunch, but we probably shouldn't. Because Angular's decided to drop the version numbering from their name. They're not going to be AngularJS, they're not going to be Angular 2, they're just going to be Angular, and they're going to pick up semantic versioning. So they're going to be iterating much more quickly, so it'll be a lot less relevant. Hopefully we'll get a lot less breaking changes, and it'll be a bit more evergreen. So we'll say Angular 2 a whole bunch just because we're transitioning, but moving forward in the whole world, hopefully it's just going to be Angular.
So who has tested Angular 1? Who's written Angular 1 tests? Only a couple of people. So who's written Angular 2 tests so far? Awesome. Well, you guys are in the right room.
Yeah. Just for the record, was it any hands went up just then?
There was 2 on Angular 1.
But any for Angular 2? Okay, cool.
Great.
We're in the right spot.
Definitely. So just before we start, a bit of history. So it was 1979 when the first time that testing was actually differentiated as a different practice from debugging. So we've been doing this a while now. In 1996, Kent Beck released XP, or wrote about extreme programming, which had a real focus on testing. And in 1988, he released SUnit, which was the first of the XUnit frameworks, which a lot of the current frameworks are still based upon. In 2001, Pivotal Labs did a JavaScript port of SUnit for JSUnit, and keep an eye out on Pivotal Labs. In 2003, TDD, Test-Driven Development, started gaining a lot of popularity. In 2006, Dan North wrote about a new way of writing tests. So it was an evolution of TDD with more human-readable tests for behaviour-driven development, and Dan's actually at the conference, so if you see him, make sure you buy him a beer. And then in 2006, we got Selenium for running our end-to-end tests. In 2010, we got Jasmine, which was by Pivotal Labs again, and that was the updated version of JSUnit. In 2010, Angular 1 came out, and this was really cool. I was really excited about this. For the first time, File New Project was test-driven. So Angular 1, from the very first version, had a real focus on testing. In 2011, Karma came out from the Google team, and I actually much preferred its original name, which was Testacular, which is pretty cool. In 2013, we got Protractor, which is how we now run our end-to-end tests, and it's using Selenium under the covers. And in 2016, we got Angular 2. Now, what's really interesting about this history is that, we're still doing TDD. Jasmine actually uses BDD. We're still using Protractor, we're using Protractor, and it uses Selenium under the covers. We're going to be writing Jasmine. So a lot of the practices we're following and the tools we're using in 2016, they're not new. They've actually been around for a really long time. So why aren't people writing tests? Well, tests aren't necessarily easy to write. It's not always easy to write code. And one of the things we're really going to come around, and one of the focuses that we want to focus on today is showing you the cool new utilities that the Angular team have put into Angular 2 that are going to make testing easier. And hopefully that will enable more people to write tests. So our agenda for today, we're going to have a look at the tools that you use to write unit tests. We're going to have a look at Jasmine. We're going to talk about then the 3 biggest challenging areas around testing, which is faking dependencies and about the Testbed API, which is a new API that the team's included in Angular 2, which is really going to help you with your tests. And the real challenges around, programming and how do you test asynchronous code. And then we're going to have a look at some end-to-end tests.
Cool, so we're going to jump in and have a look at some of the tools that are most popular for Angular 2. And I think it's good to reiterate what Adam said, that testing is not an afterthought for Angular 2. It's it was one of the most notable things about Angular 1 is when it first came out, it was all about being testable. And if you go look at the docs for Angular 2 at angular.io for testing, you try and print them out, it's about 99 pages long. It's just one long document on the web. So there's a lot to it, and there's a lot of great new things, so we'll show you some of those today. So when we're talking about what we're going to test today, we're going to be doing some unit tests, and we're going to do some end-to-end tests. So of course, the unit tests are just testing specific functionality or specific functions, and the end-to-end tests is actually running up a browser and running tests against that browser and looking at where an actual user would work with that browser or the application running in the browser. So these are kind of the default tools that everyone's using for Angular 2, even though you've got options. So for your unit tests, you'd be using Karma as your test runner. You'd get Jasmine as your testing framework and for your syntax. And then I've got Angular here because Angular is actually part of the deal. There's a whole bunch of testing utilities that you use when you're testing Angular 2. When you're running your end-to-end tests, Protractor's the default for kind of an Angular wrapper over the Selenium WebDriver, and you'll also use Jasmine in that case. So you can use Mocha and Sign-On if you're used to using those, but most people are using this combination of things. And it's what a lot of the default tooling that comes out of the box is using. So what's Jasmine look like? Well, Jasmine gives us this BDD style kind of syntax. This is an individual test. It's an it block. You could also call it a spec. And it takes a string. It's got this BDD English kind of written sentence in it. So should add 1 + 1. And then it takes an anonymous function, and then you do your testing inside that block there. And then here we're using one of the Jasmine matches, which is .toEqual, but there's lots of matches in Jasmine. So we could have an individual test like this. You would always wrap them in a describe block. So you'll have multiple tests inside of this describe block. And there's a lot of flexibility in the way of using Jasmine. You could have nested describe blocks, and each of those nested describe blocks have more it blocks in them, so you've got more individual tests. And it can go on as much as dynamically as you want to do it. So you could have this nested structure of describes and it statements. But this is kind of the general flow that you'll see. Karma's the test runner. It runs in whatever browser you want to choose out of the main browsers, and you can run it on your build server. And when you run it, you get an output in the terminal similar to this. All these tests are passing in this scenario, but just to point out the fact that Karma's your test runner. Protractor looks really similar in the terminal when it gives you the output, but of course it's fundamentally completely different because it's actually running your whole application in the browser, not just part of your application like you would in a unit test. So we can see here again, you'll get this output of tests. And we're going to be doing a few small code demos over the day, so you'll see both Protractor and Karma working. Now there's another tool that I really love.
Fanboy. Now, we've only got an hour. Duncan's actually a massive fan of Wallaby. He's actually got the first Wallaby sticker in the world.
Yep.
Literally.
He actually sent it to me. So he actually gave me a whole bunch. I've got in my bag. So if you want to come up at the end, you can get a Wallaby sticker or a magnet. So what is Wallaby? Who's heard of Wallaby.js? Okay, a couple of people. So Wallaby.js is just another test runner, but it's designed to be running tests in your IDE. So what you get is real-time feedback. So imagine you had those similar tests that I had up before. On the left here, you can see that the first test is passing and the second test is failing, and you get this red dot on it. And you also get this what you would normally get in the terminal saying what your error is in Karma in line there. So there's a lot more benefits to this. It can do code coverage and other stuff, but it's great because it gives you, this fast feedback. So you'll see us use both of these today. It does cost about $100 US, so you got to take that into account. But if you're writing lots of tests, then it can be very useful.
I actually had to run a little while for a couple of days without it, and I actually noticed how much of a productivity drop I had having to constantly jump back out to the terminal.
Yeah.
It's awesome.
So Angular CLI is not a testing tool. But the Angular CLI is something that from the community and the Google team that allow you to be able to spin up a new application really quick. And when you new up an application, an Angular 2 application, it comes with all the testing out of the box. So I mention it here just because we'll be using it today, and it's an awesome way to learn testing and start even a proper application with the Angular CLI. It comes with all your end-to-end tests and unit tests ready to go. So you just go file, new project, and then start writing tests. So if you want to learn to write tests, it's a great way to do it. So in summary, out of the tools, you want to use the Angular CLI if you want to get up and running really quickly. Karma, Protractor, and Jasmine are the default, but there are options. But almost everybody at this stage, in the early stages of testing Angular 2 in the community and all the information that's out there, everyone's using these ones. And you should check out Wallaby.js. It's a pretty handy tool. So we're going to jump on to talking about Jasmine, because what we're going to write today and all it's kind of the testing framework of choice. And I call it a framework even though we talk about syntax, because there's a lot more to it than just the syntax. So we're going to be testing some Chuck Norris jokes today. And the reason we've got this very simple little application that basically allows you to click the button and get another Chuck Norris joke is because it kind of represents the common things you need to do. You'll have a service, your Angular service will call, I see a few people chuckling, will call a HTTP request to get the next joke, and then you've got to communicate between your Angular service and your component has to bind that data, and then you've got some DOM events that you want to listen to and detect changes in your tests. So it's a nice, simple, easily to understand application to think about all those common pieces that you'll want to test. So let's jump into Visual Studio Code, and we're going to have a look at writing some very simple tests. So if we come over and have a look in the directory over here, we've got an Angular CLI application, and it's just very default version of it. And we've gone and written a joke feature that you saw on the page there. And we have this joke.component.spec file. So obviously all of your unit tests, if you're going to go down the road of using the inbuilt tools, anything with a .spec inside of this app folder is going to get run as a test by Karma, the test runner. So I'm just going to come in here and I can do a describe block in Jasmine, and I'm going to be describing a certain component here. And that component is going to be our joke component. And then inside of here I can do a Jasmine it. And here I can say something very simple like should add 1 + 1. So in this case I just need to do an expectation with Jasmine and say 1 plus 1 is going to equal 3. And of course this is going to fail because we know that's not correct. But you start to get a look at what the syntax is like. I'm going to open up a terminal here, and I'm just going to clear it out. And I've already got the application running in another terminal, but I'm just going to run ng test here. So ng is the way you get a hold of the Angular CLI, and then you can ask it to run your tests. So I'm going to ask it to run the tests. It's going to kick off Karma. All of this comes out of the box in a, once you've installed it, it's very quick to do. So it's going to run that, and it's going to say that it fails, because we know 1 + 1 = 2, not 3. So I could just obviously change that back. Karma's watching that file that was saved, and then it will rerun the test, and now we can see that the test is passing down here, and we have a successful test. But I'm going to turn this off, and I'm just going to run Wallaby instead, which will do a similar thing, but it's going to give us the output of our tests in line here. So Wallaby will kick off. It will show us, you can see it's just starting up down here in the bottom right. And as it starts up, it will then show us the green dots. So it's just another way of doing the test runner. So I could say it's 3, and then it's going to fail, and it's going to show us the output. So it's quite a nice testing experience to do it like that. So enough talking about Jasmine in that sense. Let's move on and talk about how would we actually do a really simple test to test Angular. So in that case, I could make another it block or another test, and I'm going to say it should have a title of our title here on our application, which is Chuck Norris jokes. So I'm going to jump back over and say that it should have a title of this. So I'm just going to new up a component here. So I'm just going to say const component equals a new joke component. Now this is the start of our challenges with if you're jumping into testing Angular 2 is our joke component. If I look at it here, it's giving me this, it's telling me if I want to new it up, I'm going to need a joke service. I've got a dependency on this joke service. And we're going to come back and talk about faking dependencies. But for now, I'm just going to pass in null here because I'm not actually going to test anything with the joke service. And I now have the component that I can test. So I can do an expectation and say that my component.title, and this is kind of cool. If you're used to testing with JavaScript, you might not necessarily be used to testing with TypeScript. So because we're testing with TypeScript, we get all the same IntelliSense and code completion and so forth. So I can just go, yep, I want to look at the component's title. It's already telling me in line there that it expected the string that we have. And then now the test is passing. So this is just a very quick look at how you can do a test. And we're going to jump deeper into how you would do some other tests in a second. So we had a quick look at adding 1 + 1. And then we had second test, and we looked at newing it up. So in summary with Jasmine, it is the default kind of testing framework tool for the Angular community, although there's other ones you could use. And it's a lot more than syntax. We're just using the syntax there, but there's a lot of testing helpers, and you'll see Adam show you a couple of those now.
Cool, thanks Duncan. So what I'm going to talk about is faking dependencies. And faking in the setup of dependencies is still one of the hardest parts of testing. Doesn't matter what language you've been using, when you're trying to test a particular piece of code, and that code has a whole lot of is dependent on other modules, it's very hard to isolate to just test that particular structure under test. So this is what Duncan showed. So we've got this situation where we've got a component. That component has a dependency on a service. So at the moment, we're just passing null. What we want to be able to do is our joke component depends on a HTTP service that's actually going out to the web to, a really useful API that returns Chuck Norris jokes. When we write our unit tests, we don't want those tests to be going and calling that service. So what we can do is we can go and create a fake. So we can create a fake object here. We can assign some behavior and say return a particular string, and then we can pass that fake into our joke component. That's one way of managing dependencies. Now, Jasmine gives us some helpers. So an alternative method is that we can actually create Jasmine Spies. So you can see here I'm using the Jasmine create spy object method. I pass in the name of the object that I want to make, and I pass in an array that has the functions on that object, and it's actually then going to return me a fake. What I can then do is go and say, on the joke server's getJoke method, I can then specify the behavior that I expect. And then I can pass that into the class that I want to test. So there are two different ways of managing the dependencies in our application. So the benefits of spies is that spies let you intercept any function call, and they also let you override the behavior of a function. One of the other benefits of spies is that they let us check what's actually happening on those dependencies. So I'm able to verify that the getJoke method has actually been called. I'm also able to verify how many times it was called, and I can also verify what parameters were passed to that particular method. Let's go and have a look at what that might look like in code. So what I'm going to do is I'm going to come down here and I'm going to create a new test. Okay, and what am I going to do for my test? What I'm going to say is, I'm going to say that my test should set the joke property on the component. Now let's have a little bit of a look at what I mean by that. I'm going to jump into my component and have a look. And now in here you can see when the component's initialized, it calls the getJoke method. The getJoke method goes off to my API, and then when it returns a value, it assigns it to the joke property on this class. Okay? So what I'm going to do is I could new up the component here and then go and call the ng-on-init method and then go and check that the property is correct. But before I do that, rather than declaring a new component inside every test, I'm going to jump up to the top of my describe block, and I'm going to use the before each Jasmine function, and I'm going to say before each test, what I want to do is I want to execute the following. what I want to do is I want to come in here and I want to say, I'm going to come up and I'm going to declare my component up the top. And I'm going to say that that is a joke component. And then in my before each now, I can set the component equal to a new joke component. Null. Okay, so I've just done a little bit of refactoring so that I don't have to create a new component in every test. Cool? So now for my test, what I want to do is I want to come down here and I want to say on my component, I want to call that ng on init method. That's the one that goes out, calls the service, and then assigns it to the property. Once I've done that, what I'm going to do is do an expectation. And I'm going to expect that the component's joke property is equal to something that I know. Okay? Now, this isn't going to work because we don't have a service. ng on init is going to call the service that was passed into the component when it was instantiated. But we're not passing in a component yet. So let's see what it looks like if I come along, and what I'm going to do is I'm going to come up and I'm going to create a fake joke service. And what I'm going to do is I'm going to say, in my before each, I'm going to set my fake joke service to be equal to an object. And on that object, I'm going to add my getJoke method, and I'm going to say that it returns an observable of fake joke. Now for that to work, I'm going to have to come up here and import the RxJS kitchen sync so I can get the RxJS Rx. That just lets me get the of function. Okay, so you can see what I've done there is now in my before each, I'm creating this fake object, I'm putting a getJoke method on it. That getJoke method is going to return an observable of fake joke. I can now pass that fake joke service into my joke component. When we scroll down here, we can see that I'm calling ng on init on the component, and it now knows, hey, that joke property it already is telling me that it should be equal to fake joke, and that's exactly what I would expect. Cool? And now as soon as I finish that, my test is going to pass. So that's doing it using a fake. What I can do is I'm also going to show you how to do it using a Jasmine Spy. So using a Jasmine Spy, I'd come up here and I'd go fake joke service equals, and I'm going to go jasmine.create spy object. Then I'm going to supply the name of fake joke service. And then when you create a spy object, you pass in an array that contains the methods on that object, getJoke. Okay? So now I've gone and I've created the fake joke object, and now what I need to do is just go and assign some behavior to that getJoke method. So I'm going to go fake joke service dot getJoke, and I'm going to say and return value is an observable of fake joke. And if I haven't missed anything, which I don't think I have, my test should still be passing. Okay? So that's very quickly shown you the two different ways of doing that, of creating a fake. Oh, wrong way. So what we just had a look at is, we've had a look at how to create a fake joke service and pass that in and to be able to override a dependency, and then how to create a fake using a Jasmine Spy. And the Jasmine Spy then lets us override the functionality of the method, and we could also go and check to see when, the behavior of those methods. So the benefit of faking is that it's isolated. You're actually creating a whole separate object for your service or for your dependency, and you're passing that into the component under test. Okay? The downside is you often end up with lots of duplicated code, and you can end up in the situation where when you go and change the real implementation of the service and you don't update the fake implementation, you might have tests that are passing when they really shouldn't be. The benefits of spying is that spying has additional functionality. So you can go and assert, and find out information about how that dependency is behaving, and you end up with cleaner code. So in summary, you need to know how to use both fakes and spies. And faking in the setup of dependencies is still probably the hardest part of testing. But we've got the testbed to help you out.
Yep. So we're going to move on to talking about the testbed, which is the biggest and newest and shiniest part of the Angular 2 testing. And before we jump into talking about that, we want to talk about why would we want to use the testbed, and that's because we want to do a certain type of test. Now, in the Angular community, people are talking about 3 different types of tests at the moment. The first type is talking about isolated tests. So an isolated test is when you're just looking at testing the component's class. So in our case, that's all we've been doing so far, is newing up the component. We have no HTML template yet that we're interacting with, and that's where a shallow test comes in. When you do a shallow test, you're actually going to be looking at the component's HTML template, querying it, running detect changes on it to see, as you run your test, did things change and update, and actually query the DOM and select some of the elements on it. And normally when you do a shallow test, you're only really talking about looking at one component. The last one is an integrated test, where you would actually not just test the little pieces that you need to test for a unit test, but actually passing the entire app into your kind of setup for your tests and then testing against that. We're going to look mostly at shallow tests and isolated tests today. So let's jump into talking about this testbed and how we can use it to do a shallow test. So the testbed's got this configure testing module method on it. And what it allows you to do is to make an Angular module. So in Angular 2, right at the end of their journey when they went to RTM, they came out with their own idea of modules, and they've got Angular modules. And basically it just specifies a section of code, for this section of code, these are your dependencies. So this is great for a test, because you can say, okay, I'm going to run this test. I only have these dependencies for this little section of code. So it's going to become a default way of writing tests. So you go testbed.configure testing module, and you'll have a set of things that you set up. So imports are all of your other libraries that you import, like the HTTP module. Our test has a dependency on that for the service to be able to make HTTP requests. Declarations are your components or your directives. So we've got a joke component, and that's all we're testing. So when this testbed's made, it's just going to give us these things, not all the other components in the app. And your providers are your services. So we only have one, it's just the joke service. This is a pretty simple example, but this is what our testbed will end up looking like. So this testbed does lots of things for us, but what we want to get from it is the ability to grab the DOM. So once we have this testbed, we can use it, or once we've set it up. And the big thing we want to do is get a fixture, and this is the specific terminology. So you want to get a fixture, and the fixture gives you the ability to get an instance of this component. So you'd go testbed.create component and pass it the joke component, and then you've got a fixture on it. Then we can start to access the HTML. So we can also get the component and all of its methods and properties on it, but then we can get this debugger element, and this debug element's why we're going to all this extent here, because then we can use that to be able to do some queries against the DOM. But also there's a whole lot on this testbed. It's a really big API, so we can detect changes, we can actually get it to do some dependency injection, but for now we're just focused on getting this fixture so we can get a hold of the DOM. So this is what it would look like if you wanted to do that. So we could say we want to make a joke text property, and we want to set it to the result of what we get from this p tag. So we'd say debug element.query, would query by CSS, and we'll get a hold of the p tag, which, if we remember, there's only one on our page, it's our joke. So whatever the joke comes back as. But we can also go .native element on the back, and that's really important if we were to add that on the back, because now we can query this joke text as if we would a normal DOM API. So all of the .click and so forth that you're used to doing with a DOM API you can do. So testbed's really good. It allows us to create this testing module, and then we can query the HTML templates, run detect changes, and a lot more. So let's jump into having a look at a code demo of what this looks like if we were to refactor the code that we have here. So I'm going to come in, and I'm going to delete all of Adam's hard work.
He does that a lot.
And That's going to break a few different things here, and I'm going to just make us a testbed. So it'll be testbed.create component. No, that's not what we wanted. We want to configure a testing module. So it's very similar to testing Angular or creating an Angular module itself, which is kind of exactly what this is. So we're going to have some imports, and the imports are going to be the HTTP module. And then we're going to have some declarations, which is the components themselves, and we just want the joke component here. And it's interesting here to point out we're actually passing in the real service now. So I'm going to list that in the providers array where I'd list all the services that this testing module would need. And I'm going to pass in the joke service. So I'm actually going to pass in the real joke service, and we're going to spy on that. So this is kind of a different approach, or reduce the amount of code you're writing. Normally, it takes a little longer to do. We'd mock out the HTTP part of it so that we don't accidentally slip through and call the real service. But in this case, we're going to keep it simple. So now that I have this testbed module, I'm going to need to set up a few different things up at the top here, some properties to initialize. So we're going to have a joke service, and most importantly, we're going to get a hold of a fixture. And this fixture is going to be of type component fixture, and it will be of type joke component. So once we have this fixture, we can also get a hold of the debug element. So I'm going to do one more for that, which will be debug element, and it's going to be of type debug element. So we need to go and initialize these now, but we can do that with the testbed. So I'm going to come down into our before each, and with that setup done, then we could say, okay, so this fixture is going to be testbed.create component, and then we pass it the joke component. So it might look like a lot of code here to be writing just to get to this point, but I guess this is kind of still the state of affairs for testing front-end application. You know, the challenge is all the setup at the start of your test. And once you've done this once, it gets very easy to do it again and again. I actually find it a bit easier to configure than the previous way we would have done it using the testbed. So once we have the fixture, then we can also get a hold of the creator component. So then we would get that from the fixture, and we would say component instance. And then we can get this debug element. So the debug element is going to be fixture.debug element, and that's the big thing that we want to get. But the one last thing I can do is we can see another aspect of the testbed is being able to get some help to manage our the dependencies like this service. So I can actually use it to do some dependency injection. So I'm going to take this joke service, I'm going to say that it equals the testbed, and I can just say get. This is a very short way of doing this. I like kind of the simplicity of it. So I can just say, testbed, can you go get me a joke service? And it will go and manage the dependency injection and set it to this joke service here. So with this all done, we've now got our testbed and a fixture, but I've kind of broken some of Steve-O's work down here because we're no longer spying on anything, so we're not saying what we're returning back. So I'm just going to very quickly come into the test that Adam wrote here, and at the top I'm going to show you another way of creating a spy, because we already actually have the joke service, and that would be to say spy on, and I'm going to spy on our joke service that we've set up. And in particular, I'm going to spy on the get joke method and then do the return value thing that we saw before. So that would be and.return value, and the return value will be this observable dot of and our fake joke. So with that set up, all our tests should go green again, unless I've missed something. And then you start to go, okay, so testing is kind of one of those quirky things and you have to practice it. And I know that right now all I need to actually do is just restart Wallaby. You can see I just hit the keyboard shortcut and it's spinning away at the bottom here. And I just need it to restart again and pick up the changes that I've done because we've kind of changed quite a lot. So that's working for us, and we're kind of back to where we were before, except now we have the ability to get this debug element. I can query the DOM and actually check that it's setting the joke properly. So I can come underneath here and make another test and say that it should have bound a joke to the DOM. And then in here, what I can do is I can kind of copy this spy on up from above, because I'm going to spy on that again. So I'm going to spy on the joke service and expect it to return a fake joke for me. But what I'm actually going to do is run fixture.detect changes now. So I can actually trigger change detection by using this fixture that we have. So now that's going to trigger change detection, which will call our ng on init, which will call our service. It'll hit our spy, which will bring us back the fake joke. So things are kind of set up for us here. So once I have that, what I went through all this rigmarole to do is to be able to get a hold of, to set an element here to the text of the joke. So I'm actually going to call it joke. So I'm going to get a const of joke, and that's going to be accessible through this debug element we've set up. So I can say debug.query, and then I'm going to query by, and this is a specific symbol from the Angular project, CSS. So I'm going to need to bring it in. So I'll just use the auto importer to bring it in there. And that would have added that to the top of the page for me. So once I've got this, I can say, okay, I want to query by CSS, and I really just want to query for the p tag. And I want to interact with this how I'm used to interacting with the DOM API. So I'm going to say native element to get access at it in that sense. So once I've got it, I can do an expectation against it. So I'm going to say that I expect my joke.text content is going to be equal to fake joke. And this has already jumped ahead and told me that, you know, it doesn't equal an empty string, it equals fake joke. So I can come in and just pop that in there for us. So this is, it seems like a lot of boilerplate, but you get very used to it. There's a lot of cutting and pasting that goes on, but there's a lot of very handy things the testbed allows you to do, which we're going to cover in a second as well. So now we're at this point where we're actually literally querying our HTML template and using a testbed to only have this isolated amount of code that's running versus running the whole Angular module. So we had a look then about how we set up the testbed. It looks exactly like an Angular module would, and it gave us the ability to get this querying functionality. So it's a big API. It takes time to learn. It's kind of the cornerstone of Angular 2 testing now. And it basically makes us an ng module and runs everything in a zone. So if you're anything like me, the first time you thought about this, you're like, what's a zone? But zone is basically something Adam's going to talk more about now, so I'm going to pass you over to him.
Awesome, thanks. So we're going to talk about two functions for helping you test asynchronous code. And because asynchrony adds complexity to writing JavaScript unit tests. You know, you click a button that calls a HTTP request, and you've got to wait for that to return before you can really check on, you know, what is the result. So asynchronous code is often hard to test. So what we've done previously, and you're still able to do, is use Jasmine done callbacks. So with this, you use a promise, and then when you're done, you actually call the done method. The downside of Jasmine done callbacks is they require chaining promises, handling errors, and then specifically calling done. They're not recommended with Angular 2, but you still need them for some edge cases. What we prefer to do is use the new async and fake async helpers. And the key to those is zones. Now, what is a zone? Does anyone want to tell me what a zone is? No? Yeah. So I'm going to try and give you the easiest explanation. Zones defined an execution context for asynchronous operations. So they're very cool. Essentially in Angular 2, anytime you do an asynchronous operation, it's happening inside a zone. And what happens is it says, there's an asynchronous operation happening. I'm going to put a micro task on a queue, and when that's finished, I'll remove it from the queue. So Angular 2 is always aware of what asynchronous operations are outstanding, okay? Which is very, very powerful, because now we have these two new keywords. And when you go and you wrap your test methods in either async or fake async, what it does is it says, I'm not going to use the normal zone, I'm going to use a special test zone. So now anytime I do something like call a button click inside my test, because it's in a test zone, I've called an async operation, and it's putting a micro task on the queue. So it knows I can come down and I can do something like call fixture.whenStable, And what that does is it resolves when that queue gets back down to 0. So now we're able to say, tell me when all of the asynchronous tasks in the tests are done, because then I can go and do things like detect changes and then check my expected result is as I would want it to be. Okay, so it makes managing asynchrony much easier in your tests. Fake async works similarly. The benefit of fake async, instead of needing when stable and returning a promise, it gives you a very linear test. So with fake async, what we're doing is we're calling button.click. It's going and putting a micro task on the queue in our test zone, and then you can call the tick method. And the tick method controls time. So you can go, pretend that all those are done. And then you can call detect changes, trigger change detection, and then go and do your assertions. So tick simulates the passage of time until all of the pending async requests are done, but it also lets you do, like in the example, pass in 3,000 milliseconds. Simulate 3,000 milliseconds passing before you go and detect changes and do your expectation. Let's have a look at what that might look like in a code demo. So what I'm going to do is I'm going to come in here, and Duncan took pleasure in deleting my code. I'm actually more of a steal his code kind of a guy. So for this test, I'm going to start off, and I'm going to say that what I'm going to do is I'm going to say should get next quote on button click. So the test I'm going to write is I'm going to do exactly what Duncan was doing. I'm going to say when the page first loads, we're going to call ng on init, and it's going to set a joke. My tests are better than his, so I can test when you click a button, it's actually going to go and call the get joke method, get another joke, and then set and I'm going to test the second joke's property. Yeah? But because I'm handling this button click, I want to be able to manage the asynchrony. So what I'm going to do is wrap this test in the fake async keyword. I'm going to wrap this in the fake async method. So I'm going to jump down there. So I'm going to wrap that, and I just need to import fake async so I have access to it. So now I'm going to do all the same code that Duncan was doing. I'm setting up the spy, but you know what? Instead of returning one value, I'm going to return multiple values. So the first time that I call get joke, I'm going to return an observable of fake joke. The second time, I'm going to return an observable of fake joke 2. And just to make it a bit more fun, I'm going to wait for 2 seconds before I return fake joke 2. So the first one will return immediately. The second one is going to return a different value, and it's going to mess with me by waiting 2 seconds before I do it. So how do I make that happen? Well, I'm going to take his code and copy it. What I'm going to do, so he's doing his first assertion, then I'm going to go and get a reference to the button. Okay, so once I've got the button, I can call button.click to call the click event. And then what I should be able to do then is go and check after I call the click event, I'm expecting fake joke 2 to come back, but my test is failing. Why is my test failing? Because it's rolling through before the 2 seconds has passed and I've gotten my new fake joke. So what I can come in here is I can go tick, tell it to wait 3 seconds, and I should import it because that helps. What have I done wrong? I got my button.
Changes.
Oh, I didn't call detect changes. So after I called tick, I need to run a cycle of change detection. And now my test passes. Pretty cool? Now, fake async lets me manage time. It does have some limitations, like you can't do XHR requests using it. So what I'm going to do is I'm just going to show you what this exact same test would look like if I just used async. So if I use async, import. If I use async, I can't specify the timeout because it can't control time to the same extent. But remember when down here, instead of doing tick, what I did is I said fixture dot when stable. Okay, and now once I've got fixture dot when stable, then it returns a promise. So I'm going to say then, and I'm going to then call an anonymous function. Okay, so what I'm going to do is I'm going to say when the fixture's stable, then do my detect changes and my expectation. Oops, wrong key.
Escape.
There we go. Okay, so I've moved my expectation, my detect changes and my expectation into my when stable because I can't use tick in an async method. And now, that's how you do the exact same test but using async instead of fake async. So there's Angular 2, it makes testing asynchronous code so much easier. Oops,
sorry.
Thanks. No, perfect. So we saw how click and when stable is used when writing async tests, but we're going click, tick, and then doing our assertions when we're using fake async. So the benefit of async is that it simplifies coding our asynchronous tests. The benefit of fake async over async is that the tests are all in a straight line. They appear to be synchronous. There are downsides, though, like you can't call XHR requests. So in summary, async code is edgy to get right, but the new tools are really going to help you write your tests a lot easier.
Cool. Thanks, Adam. So let's move on and talk about end-to-end tests for a second. Anyone catch Scott Allen's JavaScript patterns talk this week? Well, a couple of people. So it was really interesting. He made this offline comment at the end of it where he said, oh, less unit tests, more integration tests. And I thought that was really interesting. And he also said that he actually tests his real services rather than mocking as much. But the real interesting thing there was that he's kind of saying, you know, more integration tests, more end-to-end tests versus unit tests for his front end. And we're definitely seeing a trend towards that in people where people are going, oh, just, you know, all this mocking, all this work on the front end, I'd prefer to just do like an automated smoke test for my end-to-end test. So I thought that's really interesting, and it's kind of a trend that we're definitely seeing as well, that end-to-end tests are getting more popularity and people are kind of wanting to have more of these, even though they can be quite brittle. So end-to-end tests ensure that your integrated components function as expected. And when I say components, I'm talking about Angular components. I guess I'm just talking about all the bits of your application, because you actually run the entire application has to be running, and then you interact with it in the DOM. So we're going to write some of these tests now, and we're going to see some of the new language features with async await around TypeScript. So I'm just going to jump in and do these ones. Our last demo of the day, and we're going to do some end-to-end tests. So I'm actually just going to come back and bring up localhost again, which has our application running. So we want to come in here and we want to run a test against this, and we want to be able to grab the title. So I can come back over into our code, and I'm just going to close everything down here and open back up the directory. And what we've got is this E to E folder. So this is what Angular CLI sets up by default for you. They don't really give you too much in there. All they basically do is do all the plumbing to get Protractor working and give you some default tests. So I'm just going to hijack that default test. I've already deleted all the content that's in there, and I'm going to write a simple end-to-end test. Now there's this idea of page objects, which is like a style of doing things which I'm not going to do today, just because we'd have lots of pages open, and I just want to show you how the Protractor stuff works. So what I need to do first of all is get some helpers from Protractor. So I'm going to import from Protractor a couple of helpers here, and they're going to be the browser, which will allow us to navigate to the right page, and elements, and by for being able to do some DOM selection. So once I have that, this is going to look really familiar to the Jasmine you saw before. I'm going to have a describe block, but now I'm not describing a component, I'm describing like a web page. So it's a different kind of context. So I'm going to actually call this a page, and then I'm going to say it's the joke page. And usually you're kind of thinking about testing a user story, so it might be multiple pages. It might be like log in, go to the email, start an email, send an email, and make sure everything worked. So it's more kind of cross-cutting. But in our case, we've only got this one page, and we just want to check the title. So to start off, I'm going to say browser.get, and just navigate to the root of our application, which is the only page that we have is this, this single page just straight on the root. And what we want to do is check that this title is correct. So once I've done that, it's going to boot up the real application in the browser, navigate to this page, and then I want to actually set a property of title here. And the way I'm going to get that is to go element by.css, and this time I'm going to be querying the h1 element, which is the title. And it's a different API because you're using protractor here, and it's get text to get the text content. So once I have that, then I can do an expectation again and say that I expect the title is going to equal this string of Chuck Norris jokes. Now, I haven't got any amazing tooling here that's going to just show me green lights because obviously I've got to fire up the browser. It's more the sort of thing you'd do at the end of kind of completing a piece of work to do this integration piece. And that obviously is not meant to be there. So once this is working, I need to make sure, I'm just going to clear out our terminal here. I need to make sure the application's running, which we know it is, and then I can go ng to get a hold of the Angular CLI again, but rather than going test, like we did before for Karma, you go E to E, and this will just trigger off all the end-to-end tests with protractor. Now, it's pretty fast, so I'm actually going to push this over to the side of the page here, and I'm just going to hide this. When I run this, it's going to flash up onto the other side of the page and very quickly load up, navigate to that page, select the h1 element, read its text, and then run the test. So you have to watch pretty closely here on the spare space over onto the side here. Boots it up, tests it, and says that it fails. So let's see why that it's failing here. And it's going to say it error expect was used. So what I've done, which my wingman didn't pick up. No. I know exactly what I've done. I'm just making fun of you. So if we clear this all out, I've actually just gone and written everything straight into the describe block, which is obviously incorrect. I need to nest that into a spec. So in here I should say should have the title of Chuck Norris jokes, like so. And then in here is where we do the work that we said before. So in here, I'd just paste back in what we had. So it's in here that I'd do the browser navigation and everything else. So what we're going to do now is run that same test. So I'll move this to the side, open this up, just clear this out so we've got a bit of space. And then I run the same ng E to E. And this time, it should do the same thing, boot it up, select it, and then run the test. So if we pop back over here and have a look, you can see that it should have the title of Chuck Norris, and it's green, and it's successful. So that's kind of like a really simple test. But let's jump in and write one more test here and actually have a look at some of the new async await language features in JavaScript or in TypeScript. So I'm going to do another test, but this time what I want to do is actually want to click the button and check that the second joke is different than the first joke. So I'm going to come in and say should have a different second joke. And I need to navigate again at the start of every test, so browser.get, and we're just going to go straight to the home page. And then in here, I want to do a const of joke 1. And then that's going to be equal to the element by.css again. And this time, we're looking at the p tag, which has the joke, and we're going to call get text on it. We're going to want two of these, one for the first joke and one for the second joke after we've clicked the button. So here I'm going to go element again, and it'll be by.css. But this time I'm going to select the button. So I'll just pass in button here. And rather than calling .text, I can just call .click on it, and I'm going to execute a click. So this will go to the page, get the first joke, set it to the variable, click the button, and then we've got the second joke there, hopefully. But then we kind of introduce some issues here in doing this because potentially the second joke might not be there when I run this expectation to say that I expect the first joke is not equal, is not going to be equal to joke 2. So if we have a look at this getText function here returns a promise. So what I'm actually going to do, I could just do .then and deal with the promise in there and put my expectation in there, but what I'm actually going to do is just block on this line and use some of the new async await stuff with TypeScript. So I can say that this is an async function, totally different than the async that you saw Adam use to do with the Angular testing utility. And I'm going to get an error here saying you can't use this when you're transpiling TypeScript down to JavaScript 2015, only 2016. But we're in luck because I don't actually need to run this in the browser. I'm running this in Node that can handle JavaScript 2016 because this test execution environment is in there. So I can come back over to the config file for the TypeScript for our end-to-end tests, say, don't target ES5, target ES6 for me, and now I can use some of the new language features. So then if I come back to our test, we've got this async. I actually need to just reload the page so that the TypeScript compiler can see that I've changed its settings. So now it's not complaining about this async keyword, and I can come down here and just say await in front of this element. I really like this. I find using async await with normal JavaScript, because you've got to always catch your errors, not as sweet as when I use it with here, because if this fails, it's just going to time out, which is fine. So it's really nice to say await and block on this line for me and wait for it to be able to get that text and then run this joke. But in the meantime, I've killed our server, so I'm just going to say ng serve again to start up the application, because remember, it has to actually run the browser. So in another terminal, I can come in and run ng e to e again. So I'm going to push this over to the side like we did last time and run this. It should fire up the browser, navigate to the page, run the first test. Again, next page, check that the first joke, click the button, check the second joke. If you've got eyes like Superman, you can follow this, but it'll be pretty quick. So it boots it up, second one, and then runs it again. So I could put some stuff in here to slow it down, but I think you guys get the point of what's happening here and how this is running. And now it's running these two tests for us. So that's just a quick look into running end-to-end tests. It's a lot of fun using the Angular CLI to be able to jump in and do this stuff really quick rather than spending half a day configuring all your testing harness. And so what we just had a look at was we went and looked at just selecting the title, and then we did another one where we actually were clicking around on some buttons. So in summary for end-to-end tests, they're not a unit test, they run in the browser, and usually you're testing using user stories versus like a function. So this example is not perfect. Normally you'd be like, oh, log in, check the joke, or do some work, and then check what a normal user would do through that user story. But it helps save manual testers, and I'd love it if we had less manual testers, because I think we could have a nicer world in that time. And save some people's days. So,
that was awesome. So there's just a really important point that I think we need to call out, and is that testing is something that you just can't do sporadically. It's something that the whole team needs to practice, and they need to practice regularly. It really isn't something that you can just go and start doing straight away. It's something that does require practice, but it's definitely worth it. So what you're looking at here is my attempt to finish this while I was on the road. This is our new documentation for our Angular, because we do a lot of courses and 2-day workshops. This is our testing docs. It's basically a much longer version of what we did today with everything. So there's like 7 or 8 lessons in here, and each lesson has all these different tasks that you can complete. So we just rewrote it in Angular and Polymer. But unfortunately, it's not complete except for this section. I have to do the authentication still. But if anyone wants to directly message me, I'm happy to give it to them for free. So on Twitter, I've got an open DM. If you hit me up on Twitter, I'll give you access to it. So it's basically just the module we did today, but you can go and follow it and step through everything we've done. Excellent. Also just calling out, we're doing a 2-day Angular 2 workshop in Copenhagen in February. So I'd love to see some of you there. But in summary, what we've had a look at today is we've had a look at some tools for testing Angular 2. We had a look through how to use Jasmine, around the complexity and some solutions for managing dependencies in your test. We looked at how the Testbed API can save you a lot of work. And we looked at how async and fake async are making it a lot easier to test asynchronous code in your Angular 2. And then we ran some end-to-end tests. Look, everyone, thank you very much for coming along. Follow us on Twitter, and we hope to see you around the conference.